Hey, what's up? Today I want to talk a little bit about cables, mostly speaker cables because I need some new speaker cables. I tend to cut and patch and splice and cut my speaker cables up. They end up sort of looking like this by the end. There's one of them with some ends kind of put on, and here's another one I got that you can see they're kind of a mess. They get to be that way after a while because I need to make new cables, so I just cut and splice and make new things. These ends are all reusable as long as you get decent ends. So I'm going to take these old ones off, unsolder them, clean them all up. They can be reused. I do have a bunch of new ones here. Got a little toolbox here. I'll show you kind of my little toolbox. I've had many over the years, but I just got a little one for this room because I don't have I'm not doing a whole lot, just a little studio thing here. And this is just kind of a little peek inside the toolbox. I got a few extra ends here for making new cables. Some old ends that I've torn off that I'm going to use to make new cables. Different size ends, different connectors, all my adapters up here. I don't know if you can see them. Just for different connections and stuff I need to make. And some tools down at the bottom. Some meters and my multimeter, solder, different things like that. Bunch of jacks, which you need a lot of. So that's just kind of my toolbox at the moment. Like I said, I've had many. So I don't know. It's helpful to have something where you keep all your stuff in one spot, I guess. That way you don't have to go searching for everything. Before I started this YouTube video, I had all my cables crammed into one suitcase that I used to use when I was playing. I just carried it with all the bars. And then I had my tools were just scattered all over the place. So now I've got everything kind of in one spot. That comes in a little bit handy. Anyway, these cables seen better days, so I'm going to get rid of those. I'll cut the ends off them later and use the ends for other things. A soldering gun here. I got a lot of different soldering guns. This one is a big one. I think it's, I don't even know how many watts it is, like 40 watts or something. Got a nice big tip on it. Gets really hot. I like it for cable work because it gets hot enough just to set the cables really quick and easy together. The little ones are nice for circuit boards and stuff where you don't want to get the thing too hot and you need more precise application. But for the speakers, I like these great big huge chisel tip hot soldering irons. So to get that plugged in, one thing I kind of wanted to discuss a little bit was cables and cable quality. I know the cable companies make this huge deal about this cable's better than this one for this reason, or this one's better than that one for that reason. For speaker cables, I don't really notice much of an audible difference. Some of the ones I just showed you have got like lamp cords. I cut the cords off of an old lamp and stuff and save the wire that would plug into the wall and turn it into a speaker cable. I've used everything you can think of for speaker cables. Wires out of cars, because I just would tear a wiring harness out and save some of the wire. Maybe if I put it on an oscilloscope and dial it in really close, I could see certain frequencies that were missing or there. Audibly, I can't hear any difference for that. The only thing you want to keep in mind for speaker cables is you want something heavy duty enough for the amount of wattage you're running. So if you're running a huge 4,000 watt amp to some subs, you're gonna, you want a 10 or at least 12 gauge speaker cable. Also, the longer it is, the thicker the cable you want. For this little studio, what I'm going to use when I make these, I got this at Home Depot for $4, 75 feet. It's green, so it doesn't look horrible. Black would be better, but green works just fine. 16 gauge, which should be fine for what I'm doing here in this room. My biggest amp right now is 400 watts. I would feel safe using it up to 800 watts at least, maybe 1,000. It does have 3 wires in it. It has a ground, which I'm just going to clip off and not use. I'll use the two of the wires in it and create my speaker cables with that. I like that it's nice, and I already got one cut off here. I like that it's got a nice coating on the outside. I tend to like cables that feel solid. This gives you some protection from the wires. You don't get the wires loose and tangled up, and they're all inside this coating. So I think this will make a good speaker cable for my studio. So I'm going to use some of this. You know, you pay $1 to $2 a foot for speaker cable, and even more than that if it's already pre-made. I don't mind making my own. I get these ends. I can get these ends here on Amazon for, I don't know, $1 a piece or so if you buy them in bulk, especially. You have the end solder tabs, little plastic sleeve, and the outside piece that screws on. One thing you want to keep in mind, some of these, I don't know if you can see the insert here, some of them are plastic, and they'll have plastic inserts here, which are the insulators. The plastic ones, if you use these things over and over again, will eventually melt and short out your cables, so I don't like the plastic. This is some sort of a fiber, I don't know what it is. I've seen it made out of wood. I don't know if nowadays they make them out of wood as much, but I've seen it made out of wood, and then this is, like I said, some sort of a fiber, so it won't melt. Just something to keep in mind. The plastic ones work just fine. It's just if you're going to keep using them over and over, eventually they'll melt them, and so you'll have to get some new ones there. Just because we're on the subject, for guitar cables, because I played on the stage a lot and I never used a wireless system, some of these are like a cloth. They have a cloth sleeve around the actual cable jacket. I like that for the stage because you're always stepping on your cables, and the rubber, like this type of stuff, eventually will just get hold in it and chew it up because you keep stepping on it. These are super tough. I've had these cables for, some of them are probably 25 years old that I've had for forever. The only thing I don't like about them is when they get twisted up, they don't lay flat. They tend to, you kind of keep on twisting them so they'll lay flat on the stage because they keep, just because they're not that flexible, but they're super tough. They are a bit more money, so there is a case for spending a little more money. Also for instrument cables, you want something that's got really good shielding. Same thing with mic cables, so I don't mind spending money on shielding. If I buy my own bulk cable to make my own guitar cables, which I do all the time, just make sure you got something with good shielding, because otherwise it picks up all kinds of interference, radio stations and microwaves or whatever's going on. Anything that goes into the air, sometimes you'll pick it up on a cheap cable. If there's no shielding, you'll pick up a ridiculous amount of noise. The speaker cables don't have that problem because there's enough power going through the speaker cable that you don't have to worry about it picking anything up. It's already got enough noise to shield out everything else. But the instrument cables or anything that's not running a big signal, shielding becomes very important. So let's get started building a speaker cable here. So the first thing I do, obviously, is cut it to the length I want. This is just going to be running between two speakers. This is, I think, about 5 feet, maybe 6. I don't remember. I cut it a while ago. I just never got around to making it. But it's the length I kind of want it to be. Throw this down here, out of the way. Wire strippers. I always kind of like these better than, these are by Craftsman. I've had these for a long time. But I kind of like the ones that got they open from the front and have the little grooves right in there. You can see it. And it's got the gauges written on there. It helps to kind of use the proper gauge for the wires so you don't chew off all the little strands in your cable there. I'll grab my glasses so I can see what I'm doing here. Now I can see. So I got this kind of stripped back already. I've got black and white cable out. The green one I already snipped off because I'm not going to use it. I only need 2. 16 gauge wire, so 16 should ought to work, which is the biggest one on this one. I don't want to get any more cut off than I have to. You can always take more off, but you can't put it back on. Not that I'm worried about running out of cable because I got a crap load. And I've got 2 sizes of these two. These are the bigger ones, in case I use thicker wires. So I got just a little bit trimmed off there. In a house wire, black would be hot and white would be neutral. So I'll probably try to keep it that way in my speaker cables just for identification's sake. It doesn't really matter which one you use as long as they're the same on both sides. But if you have to take your cable apart to fix it or work on it or something, it's nice to know which one's going where. So, like I said, we've got our, where's my sleeve at? I lost it. There it is. Got our pieces here. Put this on first. I don't have the other side on, so it's not as big of a deal, but if you solder this on here and forget to put these other parts on, you gotta take it all apart to get them on afterwards, because you can't slide them over top of the parts that screw onto it. So this goes on first. You can see it's a perfect fit. So the right size around cable jacket's nice for the, you get when you buy these, get different sizes so they'll fit over different size jackets. A little insulation sleeve. Make sure you put that on next. Then the side of this on. So this has just got 2 tabs. One is up front here. It's got a little hole in it. I usually don't use the hole because it's hard to get the wire through there, and usually the wires I'm using are bigger than the hole anyways. I don't feel like drilling it out. The one in the center is going to be the tip. The one on the end, which is just this big long sleeve here, is actually connected right to the sleeve, so that's the ground. The jacket is also going to be a ground because it'll be connected right to the outside. So everything is a ground except the tip and this little connection here. That'll be where the signal comes in, and then it just grounds off to that. So solder. This has got flux in it, but I tend to use flux. Don't know where I put my flux because the container is all wrecked. Electrical tape, handy to have around. I got to open one here. Let me grab my flux real quick. You do need to be careful with this stuff because it will conduct electricity. So I like to use it to tin the jack here, and I like to use it to tin the wires because it makes the solder stick to it super good. You don't really necessarily need it if you're using rosin core solder, which this is, but I never have luck with it, so I always use it. But like I said, don't put too much on there because it will run and it'll make a mess, and it will conduct electricity. It might not short your cable out, so you might not even notice it because it'll still be working, but if you take a meter and put it on there, you'll see that it is conducting a little bit of electricity. So you want to keep that in mind if you're going to use flux. Alright, so I'm going to start by tinning everything. Tinning just means I'm going to coat it with solder. So get all these little strands pointed all in one way. I tend to like to twist them up a little bit. You want to be careful. You don't want strands sticking out because if the strand reaches across from the ground to the signal or vice versa, it'll short out. Don't want any shorts. Since this is a speaker cable, there's going to be power going through it from your power amp. If you short it out, you can burn out your power amp. Most decent power amps will have some sort of protection fuse, but that's not a guarantee it won't wreck it. And the cheaper ones might not even have that much protection. Don't want to burn your power amp out, so make sure that, and we'll test them afterwards too. I'll show you how to test them. But make sure you don't get any strands across there. That's why I said make sure you're not using too much flux too, because it will conduct electricity. And if you're really not sure, it doesn't hurt to just buy your cables. It just costs 30 times more. So I'm going to tin these. What I usually like to do is just take the wire itself and just dip it in the flux a little bit. It'll melt and run down into the cable really well, so you don't have to get it all over the place. You don't have to stick the whole thing in there. Just get the end down there a little bit. Get some solder poking out. Soldering gun's already nice and hot here. And then I usually like to get some solder on the soldering gun, just so it's already on there. And then I don't usually touch the solder to the wire. I'll just use what's on the soldering gun. Tin those up there. So you can see right there, they're silver now. They were copper colored before, so there's solder melted to and throughout the strands of the wire. Then we also want to tin the jack here. And I need to get a toothpick to do that. So what I'm going to do is I'm going to get a little bit of flux here, just a little bit. You don't want to make a mess, like I said, it'll conduct electricity. I'm going to put a little bit on there, just enough that coats it. Put a little bit on. Sometimes I like to do this at the inside of this because it keeps the cable away from the sleeve. Like when you put this thing on here, if you got a bulge out there, sometimes it'll rub through and ground out to the sleeve, which you don't want. So, alright, so these are my soldering jigs. I didn't have them in my toolbox because I just put this toolbox together like a week ago. Just because I started doing this and needed to keep everything in one spot. So I got 2 of them. They used to have magnifying glasses on them, but didn't like those. So they're just flexible little arms. You can move them in whichever way you want. And they got little roach clips on there. I guess you could use these for multiple purposes. But it's helpful to use these because they can hold on to stuff for you while you're soldering. Now, I need to get this jack here tinned. Again, I like to put the solder on the soldering iron. It's kind of backwards. Most people don't do it that way. It's not the way it's taught in textbooks, but always works for me. And these hot soldering guns are nice because, boom, it's done. If you had a soldering gun that's not too hot, it doesn't flow that easy. But like I said, for circuit boards and stuff, I do have other soldering guns that have littler tips and don't get as hot because you don't want to melt your circuit board and all the components will fall out if you get it too hot. So the inside of this one, because I'm going to put the wire on the inside. So that's tinned. So I got solder stuck on both spots I want to solder to. Now all I've really got to do is get some more solder on my gun here. I guess this is a soldering iron, not a soldering gun. Black wire is going to the tip. The white wire is going to the sleeve. So what I like to do is I like to kind of line these up so that when I get the white one soldered on there, the black one's going to be in the right position so that it'll fit. Otherwise, if you don't get it in the right spot the first time, you got to unsolder it and move it. So right about there is a good spot. I'm just going to take and solder the white one to the outside of that real quick. Again, a hot soldering gun is perfect for this. Hold it in place till it cools. If you move it around while it's cooling, it'll crack the solder and it won't make a connection. I made my first mistake here, which I'm going to show you. And it might not matter, but I want to show you this because it's about making cables. If you notice, this little clamp thing here is not going to hit the jack of the cable. It's going to hit the wires themselves. When this thing comes over the top, we want it to be to reach all the way up here, and then we don't want the wire sticking out. We just want this part of the thing sticking out. I don't think it's going to be an issue where I've got it, because this is going to slide over. It's going to have enough room over the end of it that this is going to be sticking out the back, and you won't have the wires sticking. If the wires are sticking out, you get a flimsy connection, and then it just moves around, and eventually it'll break your connections. So if you can, and it would have been really difficult to do this anyways, it doesn't hurt to have the jacket up here so you can clamp the jacket instead of just the wires. But by clamping the wires, I'm going to have more room when I slide it on there. So maybe it's a little blessing in disguise that it happened that way. Now this black wire is going to go right here to the bottom of this one. It's already kind of in place. Nice easy little thing because it's staying there for me. Doesn't always do that. Some solder on there, and I'm just going to make sure it all kind of melts together there and I get enough solder. Made a good connection. Let it cool before you wiggle it around too much. Pull it off. And now this is soldered in place. Now what I want to do periodically while I'm doing this is I want to check to make sure that I don't have any open or shorted out circuits. This little thing here, I bought this to work on my car. This works great for working on cables. It's not great for everything because it is battery in it, which is 1.5 volts, little 1.5 volt battery. If you're using this on a computer or on your car where the car computer is or anything that's got delicate circuitry, it'll send voltage. It sends voltage through itself. So you will fry potentially, or for real, fry out your digital equipment. So don't use something like this when you're working on a circuit board or something that's got, you know, a digital signal or any kind of computerized thing in it at all, because it does send a signal. For what I'm going to be doing, it works perfect. If you got connectivity, it'll just light up. If there's not, it won't. So it's just a real quick test. It doesn't tell you if there's a little bit of bleed off. So we'll check it later with the expensive meter there and make sure there's no little bit of bleed off. But I'm going to test this real quick in just a second here, just to make sure that everything's good as we go. That way, if I gotta fix something, I don't have it all put together before I have to fix it. Now what I'm going to do is I'm going to take this little tester here. So I've got white as the ground. So if I connect this little clip here to the white, then everything that's ground should light this up. So that's the sleeve, should light this up, and it does. White wire, everything, and the tip should not, and it does not, because the tip's the black wire. I'm going to take and put this on the black wire, do the exact same thing. This should only light up on the tip, not the ground, as long as I'm not touching that there. So the tip should light up, and it does. The ground or sleeve should not. If I hit the little tip thing on the side here, it will, but this isn't. So that's perfect. So far everything looks good. So another thing I want to show you real quick here, you can see how dirty this end is getting. Gets flux on it, solder on it, it burns on there, and then it doesn't work. So I got a paper towel, you can use a rag or whatever, I got it wet. I take that, just, be careful, this thing is super hot. Just go over it. I don't know if you can see that, but it's super shiny now. It's all clean. Look at how much dirt was on there. So I got all the dirt off, it'll work much better, be much hotter. Also, when you're done using your soldering gun, make sure you clean it, because the flux will stay on there and it'll pit your tip. It'll always pit anyways, because it just will happen. But if you leave it on there, it just wears your tip out faster. So always keep your soldering gun clean throughout your whatever you're doing, and make sure you clean it when you're done before you put it away. So I'm going to use these little things, which again have multiple uses. Now I'm just going to kind of clamp this in place a little bit, because I'm having a hard time getting it to cooperate. There we go. It's all bent into place. I've got some needle nose pliers in here somewhere, and I do. There we go. I like to make sure I get enough solder on there that it kind of coats the cable. As you can see on this one and the other one, I don't know if you can see it, but I've got enough that the cable is the cable is like a blob of solder soldered right to the end. If it looks like it's just sitting on there but it seems solid, I put a little more on there to coat it so that it's completely kind of covering it and holding it in place there. I don't know if you can see that or not, probably not on the camera. See how we look on the other side. That looks good. Now what I'm going to do is I'm going to test it again really quick. Just, it's good to test it throughout. That way if you got to take it apart, you don't have too much done before you got to start over. So we know that there's no major short. Now, I talked about taping these things. I kind of like taping them. You can also use heat shrink stuff, which actually is really nice too. You got to make sure you put that on first if you're going to use that too, because once you get everything together, you can't get the heat shrink over it. The heat shrink's nice because it makes a better seal, but since I'm not using that, I'm just going to use a little bit of electrical tape here. And what I want to do, I'm just going to take where the two wires are. I'm going to go around right in through here. And I'm going to go around the ground one. I'm not really going to worry about the signal one too much, because if I do one, then it won't short out to the other. You can do both, because this potentially could hit the sleeve, but I'm going to have that little plastic sleeve up over top of it to protect it. This just keeps it, because when you're putting this together, you're going to kind of squash everything in there a little bit, and it keeps them from connecting by chance. Or if you got too much solder on there and it's running, it'll cover some of it up. And if you've got a stray wire, it'll smush it down and cover it up. So I kind of like to tape it. It'll be a bit of a pain to get it through there, but makes it worth it in the end, I think. Just for a peace of mind. So I got the ground all taped. Sleeve I do not, which I'm not going to worry about. Got these little clamps I'm just going to clamp around there. With some pliers. I'll just clamp the cable in place. Just makes it a little more secure. This jacket is bigger than the clamps are, so it's going to look a little smushed in there, but so I've got that clamped around, makes it nice and secure. Got the plastic sleeve, I'm going to pull that up over top of everything. And again, this is where it kind of becomes a bit of a struggling match to get everything squashed in there. That's why I like to tape it, so when you squash it all in, it doesn't make a connection. Sleeves over the top. Pull this up. Screw it in place. And there's one end completely done. I'm going to test it right quick before I get everything all hooked back up. So sleeve works, tip should not. Tip to tip should work, crown should not. Perfect. I'm going to go ahead and do the exact same thing to the other side here. Alright, so got the tape all in place. The little plastic sleeve over everything. Bring the end up. Screw it in place. Test this one more time. So we don't have any major shorts at all. So what I'm going to do really quick, I'm going to get a little more expensive tool. This is a multimeter. Hopefully I have a multimeter. I actually like the old analog ones where they had the actual needle that moved. I do have one that I built. It was a meter that I blew up, and I took the actual meter part of it and built my own little conductance meter, because then you can see if there's a little short just by its moving. This will beep or whatever if there's conductance or not conductance. I'll show you this. So when you get one of these meters, impedance is, you want something with a good ohm meter on it. This does a little bit of everything, but the ohm meter is important because you need it for this. So I'm going to move this over to ohms. Look at the little horseshoe there. This tells you how much resistance you have. And this is kind of automatic, so I don't have to put it to settings. But here is a good example. The human body has a lot of resistance in it, so it doesn't conduct. Human body doesn't conduct electricity super well. But this is sensitive enough. If I grab both ends, you can see you've got about 900,000 ohms of resistance, going between 1 million and 900,000 between the two hands. So if you were to grab something out of your wall, there is a lot of resistance through here, but at 120 volts and unlimited current coming out of your wall, goes all the way through one arm and through the other arm, goes across your heart. That's what kills you. So you'll see a lot of people working electronics that only use one hand. This hand will be not in contact that way. If you do get a shock, it's not going from one arm to the other through your heart, because that's where the problem lies. A lot of things will make a difference in the body for impedance. How much you're sweating. I've got flux on different fingers, not on different fingers from doing this. Anyway, let's check the cable. So there's 0.5 ohms of resistance. That's how much resistance is actually in this wire. If you touch it with your hand, you'll get a much different reading because your body conducts electricity. So if you grab these with your hand while you're doing this, you're going to see your impedance change. So make sure you're not touching it. I'm holding it with this hand, but this hand's not touching it. So the amount of resistance in this actual wire is about 0.5 ohms, 0.3 ohms right now. There should be none between the tip and the sleeve. Let's see what we got here. None. That's exactly what we want. That means there's absolutely no short. Same thing applies here. So for the tip, there should be about the same. So about 0.5 ohms of resistance in the wire itself. Stabilize here. Tip in the sleeve. Oh, I'm touching the sleeve. That's why. Remember when I said not to do that? So I'm at 5 million. Keep from touching this stuff while I'm doing it. If I'm not touching it, there's nothing. As soon as you touch it, it changes. So I said you gotta be careful if you touch these things, and you can see it automatically starts changing. So this cable should be good. There's no conductance between the tip and the sleeve, which is what we want. About half ohm resistance. Now, when you make a wire longer, the resistance increases. That's why for speaker wire, or any wire, but especially the speaker wire, if you make it really long, you want a thicker wire because there'll be less resistance in a thicker wire. The thinner wire is, the more resistance is in it. So if you run a really long wire that's super thin, there'll be a lot of resistance in that wire. Theoretically, it could get hot and melt. Without a huge power amp, it probably never would, but it's possible. But it creates a lot of resistance. So the longer the wire, the heavy duty the wire you want. And like I said, it'll just run cooler. So not a bad looking speaker cable. Ends fit on there really snug, really tight. Everything's kind of nice, and certainly beats my old spliced together things that were kind of a mess there. And like I said, I'll take these ends off and they can be reused. So that's a little tidbit on wires and speaker wires, cables. Hopefully that was sort of helpful. It'll certainly save you a lot of money if you do this yourself. Be careful. If you short it out, you'll wreck stuff. I don't want you burning up your amps or anything. Guitar cables and stuff, when you make those, you don't have to worry so much about burning anything up, but if you're on stage and it shorts out and your guitar quits working, it's obviously an issue, and you want to make sure you get the shielding right on those. But if you can do this yourself, it will save you a whole lot of money. And hit the subscribe button down there. I've got a subscribe button on all my videos now. We'll hopefully have a lot more videos on this type of thing, and we'll see you next time.